So in this video, we're going to be learning about linear programming. Linear programming is a method to achieve the best outcome in a mathematical model whose requirements are represented by linear relationships. A typical example would be taking the limitations of materials and labor and then determining the best production levels for maximal profits under those conditions. It's basically trying to find what inputs give you the best outputs.
We have a problem here. For example, a kazoo factory produces two types of kazoos, a beginner kazoo that makes $20 a profit, and a limited edition kazoo that makes $60 a profit. Each kazoo is 6 centimeters squared in volume, and there are 240 centimeters squared of material available. The beginner kazoo takes 2 hours to make, and the limited edition kazoo takes 8 hours to make. There are 200 hours of labor available. Find the optimal combination of the two types of kazoos to maximize profit.
Okay, we're going to use optimization, or something called the simplex method, to find the optimal solution to our word problem. So in our word problem with the kazoos, we had two variables where A represents the expensive limited edition kazoo and B represents the cheap kazoo. So this represents our how many materials you need. So we had 6 centimeters squared of materials to make both kazoos, which was less than or equal to 240 materials. And then we had 8 hours of manual work to make the expensive kazoo and only 2 hours of work needed to make the cheap kazoo, which was less than or equal to 200 hours of work. But here we have added S1 and S2, which are our slack variables, so that we can change our inequalities into equations. And then here we have our objective function where P is equal to 60A, so $60 every time you make an expensive kazoo, and $20 are made every time you make it a cheap kazoo, and P represents our profit. So we can reduce our equation so that we can put it into our table down here. Okay, so here we can take out a 6, A plus B plus S1 is equal to 40. And then we can take out a 2 out of this right here. So 4A plus B plus S1 is equal to 100. All right, now we can start putting this into our table. So we have 1A plus 1B plus 1S1 is equal to 40. And in our second equation, we have 4A plus 1B, 1S2 is equal to 100. So now we can take our objective function and put it in the last row, but first we need to put all the variables on one side. So this will become P minus 60A minus 20B is equal to 0. So now we can put this in our table. Fill in the zeros. All right, now what we're gonna do, our objective to find our solution is to eliminate all negative numbers from this bottom row. And we're going to do a series of operations in order to get these numbers to be positive. So first, what we're going to do in order to do this is find our pivot number. So we're going to take our first number and divide it by the same number in the column as our first negative, which is 1 in our A column. So we're going to do 40 over 1 and then 100 over 4. And our pivot number, since there's two options that it could be, in order to find it, your pivot number is the smallest non-negative number. So this would be 40 and this would be 25. 25 smaller and also positive compared to 40. So our pivot number will be 4. So basically what we want to do now that we have our pivot is that what we're trying to do with all these operations that we're going to do is try and get all of the numbers that are in the same column as 4 that aren't 4. So basically the negative 60 and 1, we're going to try and make these equal to 0. And in the process, we're going to be making this a non-negative number. So basically what we're going to start out with is dividing this whole row by the pivot number. So dividing this whole row by 4. So we have 1, 1/4, 0, 1/4, 0, and 25. We can fill in all the other numbers. All right, now what we're gonna do is that's only the first step. So we've dealt with only one of our 3 rows, so we got that row out of the way. But now we gotta change our first row here. So our first row, what we're gonna do, now that we have our pivot number out of the way, we're gonna add or subtract multiples of the pivot row. So we're gonna add or subtract multiples of this row to make the elements make this 0, and also changing the other rows in the process. So we're going to take row 1, subtract it by row 2, or subtract row 2 from row 1. So basically, moving on here, we're going to have, so row 1 minus row 2 would be 0, 3/4, 1, negative 1/4, 0, and 15. And our second row is good, so we're just gonna fill that back in. And here we have now it's time to do something to our third row. So our third row is going to become, we're going to take the third row and add, so our multiple is going to be 60 times row 2. It's a little squished. So row 3 plus 60 times row 2. And that's how we're going to find our new row 3. So we're going to take row 3, which is negative 60, plus 60 times row 1, which is 1. So 60 plus negative 60 is 0. And then negative 60, or 60 times 1/4 is 15, plus negative 20 is negative 5. So both 0. So 0. We're going to have 15 divided by 4, or 15 times 1/4, which is 15. 1, because 0 plus 1 is 1. And then we're going to have row 2, which is 25 times 60, which is 1,500, plus 0, so just 1,500. Alright, so we got that first part out of the way, but the thing is we still have this negative number down here, so we're going to have to do the process over again and find our new pivot number. So basically what we're going to do is we're going to do the same thing, only since the negative is in this column, our pivot number is going to be one of these two numbers. So we're going to do 15 divided by 3/4, and 25 divided by 1/4. So that's 15, ignore that, 15 divided by 3/4. So that is equal to 20, and this is equal to 100. So the smallest non-negative number in this case is 20, so our pivot number is 3/4. So now we're going to divide this whole row by 3/4, which is the same thing as multiplying by 4/3. So we're going to have 0, 1, 4/3, negative 1/3, 0, and 15 times 4/3, 20. I think that's right, yeah. And then we can fill in the other numbers as well. Okay, so now we have our first row out of the way. So, but our second and third rows we still need to change because those have stayed the same so far in our second round of doing this. So for row 2, we're going to make it row 2 minus, so the multiple we're going to use in this case is 1/4 times row 1. So row 2, so that's 1, minus 1/4 of row 1, so 1/4 of 0, which is 0, so 1 minus 0 is just 1. So 1. Oh, we can fill in our first row numbers because they're all good, so 0, 1, 4/3, negative 1/3, 0, and 20. So now we have our 1, we have row 2, which is 1/4 minus 1/4 of 1, so 1/4 minus 1/4, 0. And then we have negative 1/3. If we do the same thing, these two numbers, it would be 1/3, because 1/12 plus 1/4 is a third. And we have 0, 20, because, yeah, 1/4 of 20 is 5, 25 minus 5 is 20. And now we have our second row all checked out, so good for that. And then we have our last row, which all we do for our last row, is row 3, we take the third row and we add our multiple, this case of the pivot, which would be this row. I'm going to do 5 times row 1. So we're just going to take this plus 5 times row 1, that would just be 0. 5 plus negative 5, 0. We're going to have 20/3 plus 0 is 20/3. We're going to take, let's see, that's going to become, 40/3. Because 1/3 plus, yeah. And then this is 1, yeah. And then this is row 3, which is 1500 plus 5 times 20, that's 1600. And we have our 1 down here because we have row 3, which is 1 plus 0 is 1. And then, yeah, so now you can see that in the bottom row, all of the numbers are positive. So we can basically cover up the S1 and S2, so we're left with our variables and our numbers here. So we have, now these two numbers are our solutions. So this is where B is equal to 20, and A is equal to 20, where P is equal to 1600. So now we can see that the optimal solution to maximize the profit, which would be 1600, in this case would be, sorry, I wrote 200, 20. Be 20 of the expensive limited edition kazoos and 20 of the cheap kazoos. And we know this works because we can plug it into our original profit equation. So 60A, so A was 20 and B was 20. And we know that equals 1600 if we plug it in. And there we go, check. That's how you find optimal solution using the simplex method.